If anyone's in the market for a 22-hour gas tank, let me know, because we're not going to need it where we're going. Every electric vehicle needs a high voltage battery setup, and that's what we're working on today with these battery modules. This is my DIY electric vehicle project. Platform is a 1982 Toyota pickup. In the last few videos, I've shown myself installing the motor and the controller and all that jazz in there. And in this video, we're going to be installing the high voltage battery pack. For this conversion, I'm using a few battery modules out of a 2014 Tesla Model S. You can see our part numbers right here. I've got 1, 2, 3, 4, 5 modules. Each of these are about 24 volts nominal with a little over 5 kilowatt hours of capacity. Altogether, these will be connected in series to make a 120 volt pack at just over 26 kilowatt hours of capacity. So in this video, we're going to be putting these in a custom enclosure so that I could mount the batteries underneath the truck. We're going to be installing these battery management boards from EV West. This is part of what's going to allow us to monitor the temperature and voltage of all the different batteries in our pack. And we are also going to install bus bars to connect all of these in series and give us those 120 volts that we need to get around in this truck. So without further ado, let's install some of these battery boards, and I'll show you guys how I'm going to install each one of these modules in the battery enclosure. One thing that you really don't want to happen if you're building your own electric vehicle and you're using this type of battery, you do not want them to overheat or overcharge and combust. And there are two main factors that you can keep an eye on throughout your vehicle's operation to ensure that this doesn't happen. One is to continuously monitor the temperature inside each battery module, and the other is to monitor the cell voltage of each little battery. You can see there's hundreds of little batteries in each of these modules. So the other part of this is to monitor the voltage of every single one of those cells and make sure it's within a safe operating range. And the way we're going to keep an eye on those two things is with this. This is a, you can call it like a BMS or a battery cell tap board. This one is from EV West. It's their Model S and X board. So this 4-pin harness, there's a 4-pin harness on each of these modules. Basically, those are thermistor outputs that you connect into this 4-pin female right here, and that allows you to read thermistor outputs, so you can monitor the temperature within the pack. And then these tap into each series connection and allows you to read the voltage of every cell in this pack. So it'll get mounted very nicely right about here inside of the plastic, of course. And then later on, we will connect our battery management system to this connector right here, and it will be sending a stream of information on the temperature and voltages to our battery management system. I will make a separate video on that because battery management is its own whole thing that's very important to get right. So let's install 1, 2, 3, 4, 5 of these boards. And after getting the boards on, we're going to put the batteries in this enclosure, and they're going to be mounted underneath the bed of the truck. All right, we've got all our boards installed, looking good, tapping in to get all the information that we need. Now we can drop them into this battery enclosure. This battery enclosure is also from EV West. This is their 456 Tesla battery module enclosure. A few things that are nice about this, there's no fastening needed, The side rails of the actual battery module itself are structural, and they just slide into each of these slots that you can see that are cut out in this plastic sort of spacer here. And that's what suspends them and holds them in place within this enclosure. Going to be stacked 1, 2, 3, and then 1, 2. Then this aluminum lid gets screwed on. There is a spot for a quick disconnect for the maintenance shutoff switch and for some data or signal wires and a USB cable to come through here, which is very nice to have. It comes with these tabs TIG welded on, it looks like, so that they can be mounted to some rails that I put in underneath the bed here. You can see that one. And there are 2 more back there that align with each of these tabs. Let's get to it. One important thing to note on these batteries, let me show with my multimeter here. If we measure across the 2 terminals here, we see 23 volts. If that was a negative 23, that would mean that this side is negative, this side is positive. But since that's positive, that means you have the correct polarity. This side, the left side, is negative, right side is positive. Something to keep in mind when you're connecting these. And as I was loading these into the enclosure, I realized that I'm not going to be able to get my bus bars in here once they're in, which is a perfect time to introduce the bus bars from EV West. Now you can make your own out of cables, however these ones look way nicer. They have this coating on them, so they are insulated. They're the high visibility for the high voltage, which you're supposed to have in automotive applications, and you know they're going to fit perfectly, so definitely a nice to have. Also got these 90-degree bus bar connectors, so let me show you guys how these are going to work. So we're going to have to jump. By the way, there are rigid plastic casings on these, otherwise I wouldn't be touching them or putting metal parts on them. So we're going to have our main negative in the pack down there on that lower one, and then we're going to jump positive to negative here. And that jump from plus to minus on bottom is going to happen using this bus bar here. So it's a nice clean way to do it. The other thing is with these 90-degree bus bars, for my main negative down there, it's going to be really tough to get to and tie in all my cables once I have all the batteries in. So this 90-degree connector actually allows me to put this on there beforehand. Let's pull these top 2 out and I can put those bus bars on. Now the other thing that we have to do with each course of batteries that we install, and the other thing that is really nice about those EV West battery boards, is that they come with a harness already made. This harness is going to go into our battery management system, and so each harness goes to 2 different BMS boards. I'm going to go ahead and plug them in one at a time each course that I go up, just because I think there's going to be pretty small clearance in there after the next one's in. So, see, battery, come on, focus. Battery number 1, beautiful. And the next one will get battery number 2. All right, that is in there. Now we can proceed with the next few courses. All right, now we got all our 5 modules in. There are no installation instructions. However, I assume the 5th board here was included as a spacer because it fits perfectly, and now this can't shift around at all. So everything is in. Well, not everything. Okay, I had one of the harnesses mixed up, but now we're good. I think I'm running out of time to work tonight. Got to go to work early in the morning. I'm gonna pick this up tomorrow. All right, I know I said I was gonna do battery management in another video, but I lied. I have to install it now, so I might as well show you guys that I'm using the Thunderstruck Motors BMSC for this build, which stands for Battery Management System Controller. This is what those prefabricated harnesses that I showed earlier will plug into. The device on the right is just a satellite, since the BMSC only has 2 ports and I need 3. This device has 12 volt power in from the key switch fuse, and it's grounded to the chassis. It also has CAN bus connections, those are the ones in the blue and green wires, which tells our charger when to turn off so that the batteries don't get overcharged. And lastly, it has the ability to turn off the main contactor and shut everything down if it sees a temperature over a predetermined cutoff point. I put mine at 40 degrees Celsius just to be safe. I made a harness using this weather-tight connector, crimping a pin onto each wire and then inserting it into the plug as shown in the instructions. Well, now we have all our harness made for our connections. Our BMS power and outputs and everything can poke through the battery box there. This battery manager also has the ability for you to run serial data from it, from this thing that kind of looks, I think it's a 3.5 millimeter aux cable. So once you plug your 3.5 millimeter cable into there, the other end is just a typical USB cable that you can plug into your computer, read any faults, read all the cell voltages and temperatures anytime you want. So in order to be able to access that, we have this little adapter, which is also from, you guessed it, EV West. And if we set this up here, we can plug in like that, poke out the other side to a USB-C, it looks like. And in order to install this, take this outer ring off, put the threaded side through the port that's already made in the box here, and then on the other side, just thread that piece back on there. We also have an Amphenol connector to install. This is a quick disconnect for our B+ and B- cables, just in case we ever need to drop that pack. And we can also pull off this access panel to make installation of things like fuses and some of the bus bars a little bit easier. So I'm sorting out some of the last loose ends here for the high voltage cabling inside the battery enclosure. We basically have to run our positive connection from the main battery pack. You can see the main positive on the 90-degree angle right down there. That has to run first through the maintenance service disconnect, so we can turn this on or off if we need to work on the vehicle and disconnect the high voltage system. It will then go from the disconnect through the main fuse here. This is a 450 amp fuse from Bussmann. And then from that fuse, it'll go to this Amphenol connector, and then that will allow us to do quick disconnect between the controller and the battery pack. There's a 90-degree fitting here that will go like this on the pack. So to address those tight corners in there, I'm going to be using some scrap copper bar that I have here, and I'm going to first just make a template out of cardboard to find out what kind of bends I need to make to be able to make that right angle connector meet up with this post on the service disconnect. And there's a very important step that we don't want to miss here, where we test our harness. So your Thunderstruck BMSC will come with this little green board. It's a test harness. What you want to do is plug your harness into here. Basically, you're gonna want to check each one of these here and make sure that they go up in roughly 3-volt increments. Ground pin's gonna go to 3-0 and stay there. So it should go up in roughly like 3.9 volt increments depending on what your state of charge is. But you just want to make sure that they're going up the way they should. Now we're basically measuring each cell by hand here. So that looks good because that's two 24-volt batteries wired in series. Now we know that this is safe to plug in to our BMSC. You're probably not going to have any problems if you're using a prefabricated harness like this one, but if you're making the harness yourself, then it's important to check that you're not wiring that incorrectly. If you put more than 50 or so volts in one of these ports, you can actually end up burning up the board. I've done that before, learned the hard way. It was like a magic puff of smoke, and you need to replace the main board in here, which is like $150. So definitely check that you've wired it right. Forgot to mention that since I'm only using 24 volts on this specific last harness, the last 6 cell taps that aren't being used here have to tie into the last cell tap on the battery that is being used. Now after I installed the closure plate onto the side of the battery enclosure there, just want to make sure that absolutely no water can ever get in here. So I'm sealing around all the openings with a silicone sealant. You can find this at Home Depot or Lowe's, and I just put it on there and tool it with my finger after, and then it should be sealed up tight. Now this battery pack is about 300 pounds at this point, so off camera I had a couple of friends help me lift it onto this transmission jack. Having it on the transmission jack will allow me to roll it under the bed and lift it into position with my impact gun. I placed the pack directly below the rails and started raising it, and I quickly realized that the jack is a bit lopsided, so I added a scissor jack on the right side to help. After lifting each side a bit at a time, I was able to get the 5/16 inch bolts and nylon locking nuts started to fasten it to the frame. Alright, we're all the way back behind the tire now. Oh, this is fun. That's so much fun. I've actually just realized that I don't want direct contact between the aluminum and the steel because that'll cause a galvanic reaction. So I'm just going to throw some neoprene slip sheets in here between each one, and then we can tighten down the bolts. Moment of truth. This is where things go great, or a giant battery falls on the ground. Coming down. Okay, I'm still alive. Okay, the transmission jack did a good job because our battery pack is up under there. It's looking solid. Good stuff. Plenty of clearance. Alright, so I've got the last piece of the puzzle here, which is the Amphenol UPC quick disconnect, so we can disconnect the battery cables and drop the pack out if we ever need to do maintenance on it. Super glad I printed out the installation instructions because, wow, they're just so clear and concise. It takes a little bit of deciphering, but I was able to do one side off camera so you guys didn't have to watch me fumble around a bunch. I don't have a pair of wire strippers big enough for this. There's this little grommet type of thing that will seal up to that orange plug once we finally put it in. Take our cable, pop it in here. Should hear a click, but now there will be 2 cables in here, and you can see there are threaded holes in the end of those lugs. I'm going to show you what we're going to put in there as a final step. So this kit comes with these other lugs that have a hole in the bottom, as well as some M5 cap head screws. And as it shows here, these are going to go down into these sockets and get fastened through those threaded holes that we saw earlier. Now it's pretty tight, so in order to do this, I'm using a little hex key and putting it into this 5mm socket, and that should give me enough room to get in there. Alright, I found a Torx bit that actually fits and put it on my little bike ratchet here. You can just put a little bit of torque on that, not too much because they're pretty small bolts. Those are nice and tight. The final step is to insert the plastic sleeve. These 2 plastic sleeves that come with the connector. Oh, okay. It felt a little bit intense. I guess that's fine. All right. That looks pretty legit. There we go. Okay, fantastic. These lines will obviously be secured to the chassis at some point, but that's on there. It feels really solid. And if I check the voltage at our contactor, I should be seeing about 120 volts here. Yep, it's about 118 volts. Well folks, now that we got high voltage to the controller, that is going to conclude our battery pack build. I know it's been a while, but this part was pretty involved, and I know I learned a lot, so hopefully some of you did too. We're in the home stretch now, so stay tuned over the next couple weeks as I hopefully get this thing on the ground and moving under its own power.